we had a story we wanted to take a closer look at, and this could be fun, Stephen. The Hatfields and the McCoys, Lakers and the Celtics. GIF versus GIF. The rivalries of our time are very storied, but one of the biggest one seems to be cooling off finally. AMD and Intel have announced a new partnership aimed at countering the surge of ARM-based designs. The companies have agreed to standardize specs of the x86 instruction set to make it easier for ISVs to write code that runs on both AMD and Intel processors without the need to create that weird fragmentation because certain instruction sets don't exactly match up to the other one, which of course penalizes performance, irritates programmers, and makes them say, well, I just want to go write for ARM because ARM is ARM and I don't care anymore. Here's the thing, though. This could have massive implications for the market because we've already seen a number of companies that have started to shift to using ARM for a variety of reasons, and that's left Intel and AMD kind of on an island being the champions of x86. Stephen, dogs and cats living together. Is this mass hysteria?
Well, Intel and AMD work together on a lot of things, and they're not the companies that they were back in the 90s and the 2000s when all of this rivalry came about. I think it is worth kind of remembering that time, though. So, as I think everyone in our audience is aware, Intel developed the what's called the x86 architecture back in the 70s and the 80s for personal computers, microcomputers, and many companies, including AMD, really, well, I don't want to say copied, but really developed their own implementations of x86 that were pretty much compatible, but not entirely compatible. I don't want to say copied because in all of these cases, it was a legal reverse engineering, not a illegal hack or copy or something like that. But essentially, what we ended up with was Intel being in the catbird seat with x86 and a bunch of other companies trying to play catch up and trying to improve on the architecture and develop competing products. In some of those were more successful. I remember my beloved AMD 4x86 processor that was able to swap in instead of a 386, and some of them were not so great. But in 1999, AMD announced that they were building a 64-bit extension to x86. Now, at that time, Intel had already connected with others to develop what was called the Itanium architecture, which was supposed to replace x86 entirely. This new architecture was jointly developed by Intel and Hewlett-Packard. It was going to be found in Unix systems. It was going to be the real deal, kind of, that old desktop stuff, push that aside and we'll have ourselves a real new modern platform. AMD took a different direction. They said, what if we figure out ways of extending x86 to have a 64-bit address space, new modern approaches to chip design, new modern approaches to hardware. And theirs was really successful. They developed their first Opteron and Athlon 64 processors and announced them real quick. And it very quickly became clear that Itanium or IA64 was really not going to get the kind of wide adoption that it should have. By that point, Intel was already working on their own implementation of AMD's 64-bit extension. They eventually settled on the name Intel 64, surprise, for their own 64-bit extension of x86. And that's kind of what you're using probably today. Even if you don't have that in your desktop or your mobile phone or your laptop, if you're a Mac user or whatever, you probably have it somewhere. I mean, it's the PlayStation CPU, it's the Xbox CPU, it's in a lot of servers, it's in, a lot of stuff. And frankly, it's pretty good. It's been expanded and extended by both AMD and Intel for many, many years, decades even. And it's gotten faster and faster. One of the big advancements was multi-core and hyper-threading. Lately, the big advancement is accelerated instructions. And yet, there are still differences in the underlying architectures between AMD and Intel that make it pretty difficult for low-level hardware engineers to work on the platform. Essentially, if you are developing an operating system or a video game or some kind of advanced software that really relies on the features of the 64-bit x86 platform, you've got to implement special, workarounds and use cases for Intel's CPUs versus AMD's CPUs, and that's not always easy to do. So that puts us to today. Today, Intel and AMD are going to join hands, and they're going to create an advisory committee that will allow them to drive the x86 64 platform forward in a more friendly way. And this is being cheered by basically everybody in the industry, because nobody wanted to see Intel and AMD doing this anymore when it comes to something as fundamental as the x86 instruction set. It's going to help everybody. It's a good thing. And like I said, too, Intel and AMD, they work together on all sorts of stuff all the time, PCI Express and all sorts of other technologies. We talked about, CXL technology, for example. Intel and AMD are right there working together on those. Why not x86?
Well, I like the fact that you talked about the reverse engineering efforts. I can remember trying to decide if I was going to go with an Intel overdrive processor or a Cyrix X486 processor, and that should tell you how old I am. But I think it's kind of appropriate now to kind of mention why this whole thing came about. And I'm going to use one of my favorite examples of all time, Weird Al. Weird Al writes parody songs. We all know that, right? But he doesn't download the sheet music for the song he's parodying. He actually transcribes it by ear. And then he rewrites the lyrics to be about food or whatever, right? Well, that means that while the song is almost the same, minus the lyrics, there's still some musical differences that you can pick up on if you listen to the songs back to back, because it's not a clean copy. And because the lyrics are so catchy, sometimes people like Don McLean will accidentally sing the wrong lyrics to his own song in concert because he's actually singing Weird Al's lyrics. And that's why programmers are so friggin' frustrated, is because AMD and Intel have never collaborated on this architecture, which means AMD looks at what Intel's doing and goes, well, we can do that, but we've got to figure out how to do it first. So they're doing the same things slightly differently. If you've ever programmed or configured a switch or a router, you know how this feels, right? Like, I know what I want it to do, but why do you guys have to use two completely different command line architectures? It's because we're trying to create differentiation, right? Initially, this was all about lock-in. It was all about getting Intel getting people to write code for Intel's chips and not for AMD's chips, so that you could unlock all these special performance things. Anybody remember MMX on a Pentium, multimedia extensions? That was a way to force developers to write code for those chips only, because AMD and Cyrix didn't have MMX instruction sets. Fast forward to today, and now it's not, oh, you need to write for my chip. It's, I'm going to go write for this completely different architecture over here because I've had it. I'm done. To quote the seminal 1995 work Hackers, Acid Burn was right. RISC architecture really did change everything. I know I say that all the time and it kind of sounds like a meme at this point, but it's true, because simplified instruction sets have effectively forced companies like Intel and AMD to rewrite the way they do instruction sets, because people that are learning how to write for instruction sets in school now don't want to write these big complicated things. They want to do something simple. They want to figure out how to iterate on that. And that's what you're seeing in the other side of the space, whether it's ARM processors, whether it's RISC-V or any other thing. They're all built around the same concepts. And then what's the alternative? Well, you go to AMD and you go to Intel, and like, well, you can get like 85% of it right, except these other 15% where the devil's in the details, and you're going to tear your hair out trying to figure out how to write for each of them. And that just means that people are going to be like, I don't care, I want to go to ARM. And I think that this is a very valuable tool for Intel and AMD, because if they can force people to write code that runs on both of these systems 95% the same, yes, they're going to lose some sales to their partner in AMD or Intel, whatever the case may be, but they're not losing that to an M4. They're not losing that to a RISC server architecture, because once those people leave, they don't come back.
Yeah, I think that that's really the undercurrent here. It's a signal from Intel and AMD that x86 is alive and well and thriving, and that x86 is not sort of a weird proprietary, diverse ecosystem, that it is a single platform, or it will be a single platform that companies can feel confident in going forward. It also hopefully will make things work better when new accelerated instruction sets are brought out and so on, which is something that Intel and AMD have been using historically to differentiate their products. For a long time, AMD's server CPUs were very, I don't want to say stripped down, but they were intended to be sort of straightforward workhorses, whereas Intel was adding all sorts of accelerated instructions and that do special purpose things and accelerate this or that application. Well, AMD has really jumped on that as well with their latest designs. They've even adopted very similar instructions in terms of accelerators in their latest server CPUs. And that has really helped a lot of applications, especially things, like AI, to work on server CPUs. Well, hopefully this group will be able to make sure that things like AI inferencing instruction sets will be consistent across Intel and AMD, and that you'll be able to not have to go to an ARM/GPU architecture in order to do AI work. So really what this is about shoring up the foundation under x86. It's about burying the hatchet between these two companies to some extent. Now, they will aggressively compete with each other in terms of hardware parts, in terms of announcements and launches and new components. And I expect that that's going to bring a wonderful new world of exciting, different directions in terms of AMD is going to do this with their efficiency cores and Intel's going to do that with their efficiency cores. But one thing we'll know for sure is that the software will run uniformly across them, and we won't have this weird environment where AMD does it this way and Intel does it that way, and we have to figure out how to reconcile those things. I think that it could be really good. But of course, the elephant in the room is ARM and RISC-V and the potential for the entire x86 ecosystem to get knocked off the pedestal. And Intel and AMD certainly don't want to see that happen.